Welcome to Science Meets Adventure. Imagine standing in freezing air, watching steam curl off a pool of water warm enough to slip into. Even though the surrounding rocks are cold and the mountains around you may be covered in snow. Now imagine something even stranger, that this same spring may have been fed by Earth's heat for thousands of years, long before modern roads, hotels, or even the first travelers who tried to understand it. So, how does a hot spring keep working for that long? What hidden engine beneath the ground keeps the water hot, year after year, century after century? That is what makes hot springs so unforgettable. They do not just look beautiful, they feel ancient. You arrive as a traveler, but the place feels older than memory itself. Steam drifts through cold air. Mineral crusts glow white, orange, or yellow around the edges. The water may be crystal clear, milky blue, rusty red, or bubbling as if the earth is quietly simmering under your feet. In some places, the smell of sulfur hangs in the air. In others, the spring sits in silence beneath pine trees, desert cliffs, or volcanic slopes. And the question always returns, where is all that heat coming from, and why hasn't it stopped? The answer begins with rain. Most hot spring water starts as ordinary water falling from the sky. Rainwater and melted snow soak into the ground and begin moving downward through tiny spaces in soil, cracks in rock, and natural underground channels. This is groundwater, and in the right landscape, it can travel surprisingly deep below the surface. Now imagine that water sinking farther and farther down through broken rock, almost like slipping through a giant maze hidden inside the earth. The deeper it goes, the hotter the surrounding rock becomes. Beneath our feet, the earth is not cold and still. It holds a huge amount of natural heat. Some of that heat has been trapped inside the planet since Earth first formed. Some comes from ongoing processes deep underground. And in certain regions, especially near volcanic zones or geothermal hotspots, that heat lies much closer to the surface than most people realize. That is where the transformation happens. The water descends cold, it rises hot. As groundwater reaches hot rock deep below ground, it begins to absorb heat. Then, because hot water is lighter and more buoyant than cold water, it starts moving upward again. It follows fractures and pathways through the rock until it finally reaches the surface. When it emerges, we see it as a hot spring. So at the simplest level, a hot spring is part of a natural cycle. Water goes down, gets heated by the earth, and comes back up. But that still leaves the biggest mystery. Why does it stay hot for thousands of years? Because in many places, the underground system never stops running. As long as three things continue to exist, the hot spring can keep flowing for an incredibly long time. A supply of water, open pathways through the rock, and a steady source of underground heat. Rain and snow keep feeding the groundwater. Cracks and fractures keep giving that water a route downward and back upward. And deep geothermal heat keeps warming it again and again. That means the hot water you see today is usually not the exact same water that was there centuries ago. New water is constantly entering the system, being heated and rising back out. The spring stays hot not because one pool of water has stayed trapped underground forever, but because the earth has kept reheating fresh water through the same hidden plumbing system over and over again. In that sense, a hot spring is not a one-time event. It is an active geological conversation between weather above and heat below. Rain falls, water sinks, rock heats it. The spring releases it. Then the cycle begins again. In stable geothermal regions, that cycle can continue for ages. This is also why hot springs are often found in specific parts of the world. You tend to find them where the Earth's crust is thinner, more fractured, or geologically active. Regions near volcanoes, tectonic boundaries, and geothermal fields are especially rich in hot springs. That is why places like Iceland, Japan, New Zealand, Yellowstone, the Andes, and parts of Turkey are famous for them. These are landscapes where the underground heat is closer to the surface and where rock formations allow water to move through the earth more easily. Now here is where the traveler's eye becomes important, because hot springs rarely look all the same. Some are calm, clear, and inviting. Some churn and spit. Some are just warm enough for a relaxing soak. Others are hot enough to burn skin in seconds. Why? Usually, it comes down to depth, heat, and speed. Water that travels deeper may reach hotter rock. Water moving through an area with strong geothermal activity may heat more intensely, and water that rises quickly may lose less heat before reaching the surface. A spring that seems peaceful may still be dangerously hot, while another nearby may be perfectly safe for bathing because the water has mixed with cooler groundwater along the way. And then there is the smell. That sharp, eggy scent you notice at many geothermal sites usually comes from sulfur-rich gases released underground. As hot water moves through rock, it dissolves minerals and can carry gases upward. By the time it reaches the surface, those minerals and gases shape the entire experience. They affect the smell, the color, the texture of nearby deposits, even the look of the surrounding landscape. That is why hot springs can leave behind brilliant mineral stains and crusts. White terraces, yellow edges, orange bands, green pools, rusty red rock. Some colors come from minerals precipitating out as the hot water cools. Others can come from microscopic life forms that thrive in hot, mineral-rich water. To a traveler, it can feel like stepping into a place painted by chemistry and heat. Have you ever looked at a hot spring and wondered whether the calm surface tells the whole story? Usually, it does not. What appears still and peaceful above ground may be connected to something dynamic and powerful below. A steaming pool in a quiet valley may be linked to deep faults, volcanic history, and a heating system that has outlasted civilizations. That is part of the thrill of visiting these places. You are not just looking at warm water, you are seeing the Earth's internal heat made visible. But this is also where adventure needs caution. Some hot springs are wonderful for soaking, but others are extremely dangerous. Never assume a spring is safe because it looks beautiful or because someone else stepped near it. In geothermal areas, temperatures can change sharply from one pool to the next. Some springs are scalding. Some have thin crusts around them with dangerously hot water just beneath the surface. Others may contain chemicals or gases that make soaking unsafe. For travelers, the best rule is simple. Respect the place. Follow marked paths. Read warning signs. Test only where it is clearly allowed and known to be safe. In managed hot spring destinations, local guidance matters. In wild geothermal zones, it matters even more. And when you do find a safe one, the experience becomes unforgettable in a different way. You feel cold air on your face and warm mineral water around your body. You smell the earth, you see steam drift into mountain light, and suddenly the science becomes physical. You are sitting inside a system powered by rainfall, rock fractures, geothermal heat, and deep time. So how do hot springs stay hot for thousands of years? Because the Earth keeps doing what it has done for ages. Water continues to fall from the sky. It seeps down through cracked rock. It reaches deep heat below the surface. It rises again, warmed by forces far older than human history. And where that natural system remains open and active, the spring keeps flowing. That is what makes hot springs so much more than scenic destinations. They are living landscapes. They are evidence that beneath even the quietest valley, the planet is still active, still warm, still working. And maybe that is why standing beside one feels so different. You are not just visiting a pool. You are standing at the surface of an ancient process that has likely been running for thousands of years, hidden below ground, patient and powerful. Thanks for exploring this natural wonder with us on Science Meets Adventure. If you enjoyed the video, learned something new, or now feel even more inspired to visit a hot spring someday, don't forget to like, share, and subscribe to Science Meets Adventure. See you in the next journey.